Good evening, everyone. So today's topic we have is the continue of the previous topic, that is isomerism 3. In the previous class we have started stereoisomers. Uh, in that we have started optical isomers. So we are going to continue with that only. So these are online live classes running daily, right from Monday to Friday. The chemistry, organic chemistry is on Tuesday and Thursday, that is 5 to 6 p.m. You can join courses, online courses, and you can get the 10% discount if you use a coupon that is HAJ10. So please join the classes and enter the coupon. So this is continuation of the topic, that is stereoisomers. In that we are going to talk about optical isomers, and as we have practice question and PYQs and homework. So we have already discussed about absolute configuration, relative configuration, enantiomers, dasteriomers. We are going to talk about the next isomer called as epimers. So far we have discussed sub 4 types of optical isomers. The fifth one is epimers or epimeric way. Epimers are the isomers which differ at second carbon only. So these are the isomers which differ at second carbon. Example. So I hope you remember that we have practiced glucose in the previous class. That is 6 carbon chain, and the second carbon contain OH, third carbon contain OH, and fourth carbon contain OH on the right side, whereas third carbon is in the left side. There is one more structure which is mannose, is having the similar structure with the glucose. The only difference is that mannose has a second carbon also on the left side. So you can see that glucose is only third carbon on the left side, whereas mannose have second and third. That means the difference between glucose and mannose is only at second position. So this is second carbon, right? This is second carbon. So these are the two compounds which have the similar formula. The glucose formula is C6H12O6, and mannose formula is again C6H12O6. They have same formula. That means they are isomers. But the difference is what? They differ at second position, which are called as epimers. Example we have is glucose and mannose. Hope it is clear for you. This. Good evening, Bhavna. You are my constant student. Very good. Very good. Right. Moving on to the sixth type called as erythro and trio configuration. For erythro and trio configuration, we want two adjacent chiral carbons. To show erythro and trio configuration, a molecule should have two adjacent chiral carbon. That means they should be two chiral carbon that should be adjacent to each other. They should be near to each other, right? So we will see an example here. Right, we'll see an example here. So I draw the structure here. I'll draw the structure here. So this is our chain of carbon, 4 chain. So first carbon contain aldehyde, last carbon contain OH, and the next two carbons you can see that these two carbons are chiral carbon which are adjacent to each other. That means these two are going to definitely show erythro and trio. But which one is erythro and which one is trio? Simply if two similar group or two higher priority group on the same site, two higher priority group. This means this is higher priority into this carbon and to this carbon between OH and H. This H has higher, OH has higher priority, hence higher priority on the opposite side. The configuration is known as erythro. Next, what I'll do, I'll draw the similar structure. Not similarly, I'll just change the configuration. can see that this are adjacent carbon, two adjacent carbon. That means there should definitely erythro and trio. But the thing is, if two higher priority in the opposite side, we call the configuration as trio. So you can see in this structure which I am drawing currently is having the OH group, that is similar group or higher priority group on the same side. So to this carbon, this H and OH attached, that's OH is higher priority. To this carbon also H and OH attached, this is having higher priority. Higher priority in the same side, we call the configuration as erythro configuration. Now we'll see what is trio, which is quite opposite to erythro, that is having the two higher priority on the opposite sides. You can see that these two have the same structure. The only difference is higher group on the higher priority in the same side. Here in this case, higher priority in the opposite side. That configuration is known as trio configuration. Simply, erythro means two higher priority in the same side, and throw two higher priorities on the opposite side, trios. Now you can see that we have put the same structure here. That means the higher priority in the same side, erythro, higher priority in the opposite side, trio. The scientists found this two configuration, that is erythro and trio configuration, in this compound only. Hence, they gave the word as erythrose, and for this sugar as trio. These are the sugars. These are the examples of carbohydrate. As the configuration is erythro and trio, they gave the name as erythrose and trios respectively. So, if you want to write the name, full name, as I told you in the previous class, that all carbohydrates, you can feel that all carbohydrates are dextroretary except fructose. That means they are always dextroretary, means they are always written as plus. You can see that I'm writing the name erythrose. I'm writing the full name with the configuration plus, because it is a carbohydrate. As it rotates, all carbohydrate rotate the plane polarized right to the right side. Hence, I'm writing plus. Coming to the D, why it is called as D? Because we know already that in relative configuration we have discussed. Carbohydrate also shows an isomerism called as relative configuration. If you find second last OH group on the right side, OH group on the right side, the configuration is D. Second last OH group on the left side, the configuration is L. Hence, in this erythrose compound, you will find in this compound, this is last, second last. If second last OH group on the right side, that is called D configuration. Hence, the name of the full name of the compound is D plus erythrose. Similarly, second last OH group D, right side D, as all carbohydrate are plus, hence the name is D plus triose. Now you can even write a mirror image. What you can do is you can just change this OH group which are on the right side, change it to the left side. That and we know that if similar group on the same side, you should call as erythrose, and second last OH group on the left side L, always plus. Similarly, I have drawn the opposite of this D plus triose. I put this left side, here it is right side. I put this right side, here it is on the left side, and you can right, higher group on the opposite side, trio configuration, and the name of the compound is triose. The only difference is between these two is they are on the opposite side. That is, you find that second last OH group on the left side, I am writing as L plus triose. So all these are called as erythro and trio configuration. So D plus erythrose, D plus triose, L plus erythrose, L plus triose. So don't forget to write D, this relative configuration, and L, and plus or minus. Minus only comes for fructose. Other carbohydrates are always are plus only. Hope it is clear for you about this. Moving on to the last one called as Epimers. This is somewhat bigger, still we practice because there are questions are also based on anomers also. So anomers are the isomers differ in newly formed OH group. These are the isomers which differ in newly formed OH group. Isomers which differ in newly formed OH group are called as anomers. So, so what we do is we actually understand this by drawing the structure. So what I'm doing is I'm drawing a chain of 6 carbon. First carbon contain aldehyde, last carbon contain CH2OH. You didn't get the last class. Why didn't you get the last class? I kept in the I conducted on the Tuesday, right? I think the videos is available, right? You can watch the video. Please watch the video, Bhuvna. Wait a minute, we'll practice anomers. So let us practice anomers, which are the isomers which differ at newly formed OH group. You know that I'm drawing glucose. Dry chain of 6 carbon. First carbon contain aldehyde, last carbon contains CH2OH, third carbon ka OH you put in the left side. Third carbon ka OH in the left side, others OH in the right side. So this is your open chain structure, which is nothing but D plus glucose. You know, there were scientists who observed that glucose also exists in cyclic form. There was a scientist called as Fisher. He said that glucose also exists in cyclic form. How the glucose exists in cyclic form is this H of fifth carbon, which is gets migrated towards this okay. You know how the anomers will be there? This H will get migrated towards first carbon, that is carbonyl oxygen. Just wait a minute, man. This is disturbing a lot. I'll just reopen this. this is shifting automatically. So I can show here that anomers, nothing but newly formed OH group on the they differ in newly formed OH group. You can see that in this glucose, which is open chain, this H of this will get migrated towards this oxygen. Hence, this will become definitely OH, right? What I'm doing is the shifted one, H1, H is as hydrogen is shifting, it is becoming OH. The OH I'm putting on the right side, or I can even put on the left side. The similar thing, only the difference is the first carbon O is becoming OH. Hence, there's a link between first and fifth. And the difference between these two structures is I have drawn the OH on the right side, left side. I am drawing on the right side. Hence, these are the molecules which differ in newly formed OH group are called as anomers. You can see that these two are formed from glucose by shifting of H to this carbonyl oxygen. That H becomes OH, and this OH can come on the right side, can come on the left side. These two, which differ in newly formed OH group, called as anomers. And now there are two types of anomers: alpha and beta anomers. Alpha means right side, and beta means left side. If newly formed OH group on the left side, beta, right side alpha. You can see in this compound that newly formed OH group on the left came on the left side. It's known as beta, as the name is G plus glucose, and newly formed OH group on the right side I'm writing as alpha G plus glucose. These two structures are called as Fisher structures. Fisher structures, and the isomers are called as anomers. There is one more scientist whose name is Haber. He has drawn the structure of glucose in the form of like this. So there is another scientist called as Haber who have drawn this structure in the form of cyclic ring. So look here, the cyclic ring containing oxygen are 2. 1, 2, 3, 4, 5 and 6 is oxygen. 6-member ring containing oxygen is known as pyran, and 5-member ring containing oxygen is known as furan. Havard said, this scientist said, our glucose looks like pyran. Our glucose looks like pyran if you draw in the form of cyclic. Hence, what we'll do is we draw the structure in the form of pyran. Okay, let us draw this structure. What I'm doing, I'm drawing this glucose in the form of pyran. So how to draw is, look here, draw a horizontal form. Yeah, I better tell you here. So this draw this form which is horizontal one. Now do one thing is, you know, right, the link is between first, second, third, fourth, fifth, sixth. The link is between first and fifth. Hence this position 1, 2, 3, 4, fifth position, and you can see that fifth have CH2 group outside the ring. Hence I'll do like that outside the ring. And the next, right, glucose have the third OH on the left side. Here we don't have right and left. Here we have above and below. Hence, what I do is, please remember that alpha means right side and below, whereas beta means left side and above. And you know what? In glucose, third OH is on the left side. Left side means above. I need to draw. The rest of them, the rest of the OH below. Hence, I'm writing below. But leave the first one, you do at the end. Now, if you want beta, beta means above, alpha means right side or below, whereas beta means left side and above. Hence, if you want alpha, I'm drawing below. I'm drawing the first carbon OH below, and here in this case, I'm drawing the first OH above. This is nothing but alpha D plus gluco, as I'm writing in the form of pyran, and the name of the compound is pyranose. And this is nothing but beta D glucopyranose. Glucopyranose. So you can see that glucose looks like pyran, hence I'm writing the name as glucopyranose. These are the 5 possible structures of glucose. The one is open chain, 2 are Fisheye structures, and 2 are Hajera. This open chain is only one. Closed chain are 5. Closed chain are 4. 2 are Fisheye, 2 are Hajera. Moving on to the fructose, you can see fructose. Fructose is again a 6 numbering. The only thing is fructose has keto at the second position. Hence, this H will get migrated towards this. It will become OH, right? And what I'm doing is, this it will become OH, right? This will become just give a minute. I'll just give a minute. This is changing a lot. That's why I'm just restarting it. We were discussing about fructose, right? Let us just go back to fructose structure. So we know that is a glucose isomer only, but the difference of glucose and fructose is that glucose is aldehyde, ketone has ketone group, fructose has ketone group. Hence, this H similar to the glucose, it migrated towards the carbonyl oxygen, but the carbonyl oxygen here is at second position. Hence, it goes here. Then this will become OH, right? You can see that second carbon OH became O became OH. What I'll do is I'll just shift this to this that side so that I can make a link here, and the link is formed here. And newly formed again OH group came on the right side. It can come on the left side. Again, this is called as anomers. These two structures are called as Fisheye structures or Fisheye projections. And the newly formed OH group on the right side I call as D. The newly formed OH group on the left side I am calling as B. Newly formed OH group on the right side I am calling as alpha. Newly formed OH group on the left side I am calling as beta. And the full name is D alpha D minus fructose. We have already discussed that fructose is levohereditary, hence fructose always will get minus charge, minus sign. Alpha D minus fructose, and this will be beta D minus fructose. What I'll do is again we are drawing this Hayward structure. These are called as Hayward structures, right? Now what we did, Hayward drew the structure of fructose in the form of furan, because furan is the cyclic form is it's a member of 5, right? 5 member ring. 1, 2, 3, 4, and oxygen is 5. And cyclic form of fructose looks like 5 member ring, that is like pyran. Hence we are drawing in the form of pyran. Here we are drawing here, and you can see that for this is first carbon, second, third, fourth, fifth, sixth. Sixth and first CH2OH are outside the ring. Hence first carbon, second carbon, third carbon, fourth, fifth, sixth. Fourth and sixth are outside the ring, yes. And if first carbon, second carbon, OH group below I'm writing. If it is below, right? Below means alpha and beta. So this I have drawn the newly formed OH group which is at second position below. Below means alpha D minus, and as you know, right, fructose looks like furan, hence I'm writing it as fructofuranose, and this will be just changing in this, reversing this one. That's all. It will be beta D minus fructofuranose. These are two structures, Hayward structures or Hayward projections. These are two Fisheye structures. Right. With this we finish your anomers. Moving on to the very important thing here is there are chiral carbons are found in glucose, as this shows optical isomerism. Optical isomers come from definitely shows chiral carbon. So the open chain and cyclic form of glucose contain 4 and 5 respectively. That means there are 4 in the open chain and 5 in the cyclic form. Whereas in case of fructose, there are 3 in the open chain and 4 in the cyclic form. Please remember the ratio 4. Please remember the number of chiral carbons in open chain in cyclic form of glucose are 4 and 5. This is for glucose. And for fructose, open chain and cyclic form contain 3 and 4 respectively in fructose. So with this we have finished optical isomers. Moving on to the practice questions. Before we move on to practice questions, let us download the Spark Academy app, where you can find the many exciting discounts on our courses. So you will find the handwritten notes, study materials, PYQs, and you can do the weekly mock test. And if you want to download our Spark Academy app, you will find the link in the description. And we provide all the courses like long-term crash course mock tests, whereas for all entrance exams like Eamcet, NEET, JEE Mains, IIT Foundations. And you will find the courses available in 2 branches like Mehdipatnam and Naranguda. You can join the offline and online courses, and we even have started crash course for this upcoming test. since 2022, and you will find various videos available in live classes on our app, assignments for the students, test series for the students, and again analysis for the test. The thing is, we have highly experienced faculty in a Spark Academy. We give personalized coaching, and we have limited batch size. We give pers- basic concepts right from the starting, shortcuts in all model papers, exercise questions, PYQs, grant tests, mock tests, and all. So you can download the app and you can join our courses by enrolling and typing HAJ10 code to get 10% discount online and offline. Let us go to the practice questions. So the question is, how many number of chiral carbons are found in alpha D plus glucose? So how many total number of chiral carbons found in alpha D glucose? You can see that if they are telling the word alpha and beta, that means this is cyclic form. Wherever alpha and beta comes in glucose and fructose, that is cyclic form. And you know that cyclic form has, very good, Bhavana has answered. Cyclic form of glucose has 5 chiral carbons. Very good. Yes. Just now we have discussed 4 and 5, the ratio. It's not a ratio actually, it's a number. It should not be a ratio. It should not be called as a ratio. We'll write better and. It should not be a ratio. Let us be specific. Next question. Identify the Fisheye structure of glucose. Definitely Fisheye means definitely you will have alpha and beta. And you know, right, pyranose only comes in. I don't know what happened to this. This is moving continuously. So identify the fructose Fisheye structure. So you know that Fisheye structures have no pyranose written. That means we will delete the A and B options. A and B, right? Sorry, A and C options will delete. A and C, because A and C has written pyranose. A has written pyranose. Hence, I have deleted A and C. Moving on to the B and D, where you will find that beta alpha D minus. Oh, she's answering. Here you will find that it is D beta alpha D minus. Glucose will never be minus, right? Hence, what we'll do is we'll check the one which is having plus. That means the answer is going to be D, because here it is minus, here it is plus. Glucose cannot be minus, then the answer is D for the next one. Moving on to the next question, identify the L plus erythros. Erythro means they should have the similar group on the same side, whereas L means on the second last group on the left side. That means the answer is going to be similar group on the same side, but this is plus. Similar group on the same side and second last OH group on the left side. That means the answer is going to be D again. Very good, Bhavana. You are answering very fastly. Very good. So let us go to the question, which of the following molecule does not exhibit optical isomerism? Which of the following molecule does not exhibit optical isomerism? For optical isomerism, there should be a chiral carbon, right? What do you think which does not have chiral carbon? Lactic acid, malic acid, tartaric acid? The answer is malic acid, because malic acid have carbon-carbon double bond. You will not find carbon-carbon single bond. Hence, malic acid is the answer for this. I think I already gave this for in the previous. Just I'm discussing the key for that. Moving on to the next one, which is the following molecule is expected to show uh, expected to rotate the plane polarized light. You need to pick up the one which have chiral carbon, right? Because chiral carbon only exhibits optical isomerism. Then only they will only rotate the plane polarized light. Hence, the answer is going to be yeah, very good. Yes. Corporate I think this is A, because A have chiral carbon. You can find here. You can find here, right? This is having chiral carbon. This is not a chiral carbon. This is not a chiral carbon. This is not a chiral carbon. And the answer is A for this one also. Moving on to the next question. Which of the following shows asymmetric carbon atom? Asymmetric means again they are asking indirectly chiral carbon. So what do you think where the chiral carbon is found? I want the carbon attached to 4 different groups. What do you think the answer is? First option? No, I don't think the first option, because first carbon has no 4 different groups. You can find the 2 similar hydrogens, right? This is not a chiral carbon. This is not a chiral carbon. Again, this is not a chiral carbon. This is a chiral carbon. Oh, this is not a chiral carbon because here also is not a chiral carbon. They are not chiral carbon. This is not a chiral carbon. I think the answer is going to be the D one, because D have OH, CH3HC. The answer is D. Right. Last one. Only 2 isomers are possible for. Only 2 isomers of monochloro product is possible of. So we want 2 monochloro compounds. Let us draw this butane. Butane is that is okay. What is the answer for the last one? And butane to methyl. Oh God. So what is the next question? The isomer which have 2 monochloro products. Butane, benzene, 2,4-dichloromethyl pentane, or 1-methyl propane. What is the answer for this? What is the answer for this? The answer is A. The answer is A for that. The answer is A for this, the last one. Because butane have like CH3, CH2, CH2, CH3. You can put the chlorine at first carbon, you can put the chlorine at second position. Hence, the answer is A. Let us go to the So the question is, assign erythro and trio configuration for this. Assign erythro and trio configuration for this. So what do you think? It's erythro or trio configuration? First, just check whether that there are two chiral carbons or not adjacent to each other. Yes, there are two chiral carbons adjacent to each other. Hence, here this will be Cl. You can find here chlorine OH, HF. In this carbon, chlorine attached to carbon attached to chlorine and OH. You know, right? Chlorine has higher priority. That means chlorine came on the right chain. Here, in this case, fluorine and hydrogen are attached. Fluorine is attached to the left side. You can see that higher priority in the opposite side. If higher priority in the opposite side, the configuration is said to be triol. Very good, triols. Moving on to the next one. Oh, let us go to the absolute configuration. So assign the absolute configuration for this. So you can will start numbering. This is carbon attached hydrogen carbon OH. This OH will have higher priority. That's why I'm writing as 1. And next above carbon or below carbon. I think already told you that RD is higher priority than, and above carbon will be 2. It means right side I'm getting as 1. Above I'm getting as 2, and below I'm getting as 3, and the fourth I'm getting here. So how do you rotate? As you are getting 1, as you are getting 1 the right side, above 2. So 1, 2, 3, 4, rotating to the where it is moving to the anti-clockwise direction. Anti-clockwise means S, but if fourth priority is a horizontal line, will change the configuration. That means it will be R. It means the answer is going to be 2R. 2R, that means the answer lies between 2A and E. Let us go to the second one. Here you see that chlorine, OH, carbon, below carbon. So what do you think which is higher priority? Chlorine, that means I'm getting numbering 1 to this, 2 to this carbon, above 3, below 4. And if you move to this, it will be right, left, then above means it will be moving to the right clockwise direction. Clockwise means right R, and fourth priority below only, hence it will be R only. That means the answer is to be 2R or 3R. 2R and 3R. The answer is again A. Yes, RR. Right. Yes, A. 2R, 3R. Very good. Right, moving on to the next one. So what is this? Identify the Haworth structure. Identify the Haworth structure. Haworth structure. So this is fructose. You want the Haworth structure of fructose. You know Haworth structure means you should get furanose. Here all are getting furanose. Now let us go to the structures. Here that is written as B alpha T alpha beta minus. You don't get alpha beta together. Hence, A be deleted. Moving on to the B1. B is like alpha minus fructose. They are not writing L or D, right? That means again B is going to delete it. I mean, I'll be deleting A and B because it has different in its wrong name. Moving on to the C1, it has got alpha D minus fructose. Yeah, it looks right. The answer is C, but let us just check why D is not right. You can see that D has beta D plus that I already discussed in the previous day, in the previous class, in today's class also, that fructose cannot be plus, hence it is always be minus, and the answer is going to be C. That was a homework, but still I gave the answers. Yes. Oh, D, Bhavna. Wrong. The answer is C, right? They are asking the Harvard structure. So with this, we finished today's class. So you can find the material, you can find the notes also available in Telegram. The again link is in the description. Please join the Telegram group. You will find the many notes and test series updates. And at the end, what I can do is I'm even uploading this PPTs which I'm daily taking, so that you can write your notes daily and you can maintain the notes daily. Thank you for the class, and again please subscribe to our channel and press the bell icon for notification, so that next classes you will be having a notification for new topics. Yes, thank you, Bhavana. Thank you, everyone. We'll meet on Tuesday at again 5 to 6. Next topic will be cleavage. Next topic will be geometrical isomers. Today we have finished optical isomers, right? The next topic will be geometrical and conformers. Thank you.